This is a demonstration of a somewhat to-do application using AWS Lambda, DynamoDB, API Gateway, and Route 53 up in the cloud. I'm using SLS here for the serverless framework. I have a bunch of Lambdas basically in this project. Think of it, it's like a to-do application with notes and all that. But as you can see, we have different functionalities that we can do with the notes table that is inside of DynamoDB. So if we take a look at DynamoDB right here, again, this is not really a tutorial, it's just a demonstration. You can see we have a notes table that's called SLS Notes Backend Prod, and it's basically got these items inside of here. Let's see what else we've got going on here. You could look at a field here, but it's got these elements in here. It's got a global secondary index, which ends up using a different storage space allocation. It has a totally different partition key. So this one's got like a partition key of node ID. And right inside of here, the true key itself. So the true key itself is primary partition is user ID timestamp, and then the global secondary one is basically going to have like a node ID right there as its partition key without a sort key. Anyhow, this also is using API Gateway that we went ahead or I should say we or whatever, released into production. And since we're using cores, we have the options method for the pre-flight request. As you can see, like for each of these URLs, these URLs up here have the fully qualified Amazon name. But what we're doing to get around it, like if we want to call it inside of Postman right up here, is we've got an environment set up for each and every one of these. If you take a look at here, I'm pointing to HTTPS API tbcosic.com v1, which is totally different. That's in a prod environment here. If we take a look at dev and look at the environment name, it's localhost 3000 prod, so we can go back and forth between the two. But what I wanted to get at is the reason how we got around that is by using API tbcosic.com is I have a domain and I created a wildcard, if you will, subdomain, which is API tbcosic.a, which are A records. And we used ACM, the Amazon Certificate Manager right here to go ahead and create a CNAME record for this, and behind the scenes it uses a CloudFront distribution to mask that API to the proper edge location. In my case happens to be north of Virginia. So anyways, that's how we're able to get around not having to call this full name here. So if I go back to, like, let's say for example, let's just do a get right here. If I do a get for all nodes and I have it pointing to my dev environment, the reason, let's see here, the reason why we're going to go ahead and get records here is because I've got my SLS server running offline. So it's basically in offline mode. And so it's running the, if you will, the offline Amazon environment locally. Now, just to prove that it really is using that, if I were to Control C out of that and do this again, this should hang, not hang, but it'll just say not found. Now, if I go ahead and switch it to production, hit send, this time it should come back. And the reason it comes back is because the environment variable through Postman is now using this value, which is API tbcosic.com/v1, which we have mapped up into the AWS Certificate Manager right inside of here. And if you take a look at Route 53, we've got it set there. So anyways, there it's hitting this Lambda. Now, the other thing that I have that I wanted to mention is we have pipeline. So we're able to go ahead and make changes, and I could demo this in another demo, but I'm using Git. So the idea is you make changes locally back here, and then you can take, and then you go ahead and check it into your dev branch, and then you merge your dev branch into your prod branch. And we have a pipeline, it's a code pipeline that actually gets kicked off. So if we take a look at this right here, this pipeline, it's basically taking a look at changes to code commit, and then it goes ahead and executes this down into code build. And if you take a look at the console log here, you can actually see that it pulled out from the code commit repo. So it pulls it out from the master branch with a change that we put up there. And then basically it's just installing the serverless framework inside of a container so that it can go ahead and create the proper artifacts, which it ends up using the serverless YAML right here. And it's going to go ahead and use buildspec.yml so this is what actually gets run from the pipeline actually on the container itself. So it's actually going to install serverless, the npm install for the package.json. So it's pulling down all the code from the dev repository on the container. It's running serverless, running the install, and then it actually runs the SLS deploy with the environment name. And so that's actually deploying on the container, running on AWS inside of here into Lambda and API gateway. So it'll actually deploy your new API gateway here. But if I take a look at Lambda, you'll be able to see all the methods that were deployed by the serverless framework. So here you go. So here's our SLS. As you can see right here, if I click on these right here, let's as you can see, this is the Lambda function that we actually uploaded. And so the idea is you do all of your changes here locally, check it into dev, push it up to your code commit, and then do a basically a merge to master, push that up to the code commit, which in turn forces code build pipeline or code build to execute within the code pipeline, and then it'll deploy everything properly to Lambda, the new API gateway. Also, one other kind of cool feature that we have here is the ability inside of here to use your hosted zones in the serverless YML. So this is where we specify our API domain name and the certificate. So that's just a quick demo. I'll go into more detail in some other videos. I'm taking some courses on this as well to further my understanding. And that's it for now. Thanks for watching.